Our civilization runs on a massive amount of energy, but it's nothing compared to the power our planet receives every second from the sun. The Kardashev Scale measures a civilization's progress by the energy it can use. A Type 1 civilization has mastered all the energy on its planet. A Type 2 controls its star, and a Type 3 its entire galaxy. So, where are we on this scale? We're a Type 0.73 civilization, mostly because we still get our energy from burning fossil fuels. Becoming a true Type 1 will be the greatest project in human history. So, how do we get there? It starts by solving our most fundamental problem. We have to get the power. Step 1. Switch to limitless power. Today we get most of our energy from fossil fuels. We know this is a dead end. They're finite, and we can't build a future on them. The first step is to switch to sources that practically never run out. This means a massive upgrade to renewables, vast solar farms using highly efficient perovskite cells, turbines riding the constant high-altitude jet stream, and tapping the immense heat from the Earth's core for geothermal power. The ultimate goal, though, is mastering nuclear fusion, creating a miniature star here on Earth. By fusing hydrogen atoms, these reactors release enormous amounts of clean energy. The main fuel is an isotope found in regular seawater, making our energy supply essentially limitless. But all this power is useless if it's in the wrong place. We have to distribute the power. Step 2. Construct a planetary supergrid. A fusion reactor in one place is useless if it can't power a city on the other side of the planet. Our current grids are disconnected and lose a lot of energy. We'd need a single, intelligent network for the whole world. This supergrid would use two key technologies. First, room temperature superconductors that let electricity travel thousands of kilometers with almost no energy loss. Second, a powerful AI to manage the whole system. This AI would balance power across the globe in real time and control huge energy storage systems like gravity batteries. It could even reroute power instantly around any damage, making large-scale blackouts impossible. This planetary grid gives us the ability to stop just living on Earth and start actively managing it. It's time to use the power on the planet. Step 3. Master planetary climate control. All this energy use creates a new problem: waste heat. To keep our planet stable, we'd need to build a global thermostat. This system would do two things. First, we heal past damage by pulling huge amounts of carbon directly out of the air. Second, manage the present by using giant orbital radiators to safely beam excess heat into space. But real mastery means precision weather control. We could develop the power to weaken hurricanes before they make landfall, or create rain to stop devastating droughts. The planetary AI would monitor the entire biosphere to keep it perfectly balanced. This immediately creates a social problem. Who gets to decide the weather? If we can move rain from one place to another, who makes that call? To wield this power safely, we'd have to agree on things on a global scale. We would have to organize the people. Step 4. Foster global collaboration. If competing countries can control the climate, they would almost certainly use it as a weapon. This new level of power forces us to upgrade how we cooperate. The solution might not be a single world government, but a technological one. Imagine a global AI-managed information system that gives everyone access to the same verified data, a single source of truth that helps us sort fact from fiction. With everyone working from the same basic information, we could make huge decisions together. A valuable asteroid, for example, wouldn't be a prize for one country, but a resource for the entire species. Once humanity can cooperate on this scale, we can finally redesign the nature of work itself. It's time to revolutionize the work. Step 5. Automate labor with advanced AI. With humanity working together, we can hand over the keys to the machines. AI and advanced robotics would take over the jobs needed to run our global civilization. The dangerous work, like deep Earth mining and orbital construction. The repetitive work, like farming and logistics. And the massive work, like building entire cities with fleets of drones and 3D printers. For the first time in history, work would become optional. With our survival and comfort guaranteed by automation, we'd be free to focus on exploration, creativity, and science. But this new hyper-productive economy needs a huge amount of raw materials. To build everything we need without stripping our planet bare, we have to look up. It's time to secure the resources. Step 6. Expand into space. To get these raw materials, we'd have to go to space. We'd send autonomous machines to mine the asteroid belt for metals and set up bases on the moon to harvest helium-3, a perfect fuel for our fusion reactors. The biggest advantage is moving our heavy industries off the planet to protect Earth's environment. A giant space elevator would act like a cosmic highway, moving materials up to huge factories in orbit. And for the first time, large numbers of people would live in space permanently, inside enormous rotating habitats called O'Neill cylinders, which create their own artificial gravity. But having all this valuable infrastructure and all these people in space creates a massive new vulnerability. Everything is exposed. The final step is to protect the investment. Step 7. Develop planetary defense systems. All this new infrastructure is vulnerable. The final step is to build a defense system that protects us from any major threat, whether it's from space or from Earth. For cosmic threats, we'd have an artificial magnetosphere to shield the planet from solar flares. A sensor web would track any dangerous asteroids, which could be destroyed by powerful lasers. And robotic janitors would constantly clear orbital debris. For threats at home, we could use our energy grid to stabilize supervolcanoes and tectonic plates. An AI-powered global immune system could stop pandemics before they even start. And the same AI that connects humanity would prevent anyone from starting a catastrophic technological war. This defense grid is the final piece of the puzzle, making our civilization truly safe. So, what do all these steps really mean? Becoming a Type 1 civilization isn't about hitting a high score on some cosmic chart. It's about our long-term survival. It's the journey we'd have to take to go from a fragile, competing species to a mature, unified civilization ready to face the universe. The physics allows it, the technology is within our reach. The only true obstacle is, and always will be, us.